Hello friends, welcome to our channel. Today we are starting a new series of mathematics of higher studies. Now today the topic is about higher order derivative, where we mainly study about the Leibniz theorem, which states that if u and v be two different functions of x, then the nth derivative of their product, that is u and v, is given by the formula this. Un minus 1, un minus 2, these terms are the differentiation of the original functions u and v with respect to x. Now we can solve the question which are asked to solve by Leibniz theorem. This is a question which is asked multiple times by many colleges like PoU, TU. So this is question: if y equal to sine inverse x, then show that 1 minus x square y2 minus x y1 equal to 0, and 1 minus x square yn plus 2 plus 2n plus 1 x yn plus 1 minus n square yn equal to 0. So how to solve this? To solve this, we can write the original question: y equal to sine inverse x. At the initial state, we mainly differentiate it with respect to x. So differentiating with respect to x, y1, mainly when we differentiate in higher study, we can simply write y1 equal to the derivative of sine inverse x is simply write it as the 1 by the root 1 minus x square. So the derivative of sine inverse x is 1 by 1 minus x square. Now multiplying this goes to there, 1 minus x square y1 equal to 1. Now we can square both to eliminate this under root. So s squaring both sides. Now this root term eliminates, 1 minus x square y1 square equal to 1. This is the equation I. And is one solution which is like this. We should again differentiate it. So for again differentiating with respect to x, this is in the term of u fx equal to u v d dx. For this, we simply take one variable, first one variable as constant, and differentiate the another variable. So u dv by dx plus v du by dx. So here we can simply take the term 1 minus x square as u and y1 square as v. So 1 minus x square, the derivative of this 2y1 with respect to, again derivating y1 with respect to x, this is y2. So plus term, again now this term becomes constant, so y1 square, and the derivative of this 1 minus x square term is minus 2x. This is becomes 0. The constant of the derivative of a constant is always 0. Here we can easily see that there is 2y1 is in common, so we take this 2y1, then it remains 1 minus x square y2 minus x y1 equal to 0, or this multiply with the 0, so it becomes 0. Now 1 minus x square y2 minus x y1 equal to 0. This is the equation 2. Now we can easily see that there is two term u v also there, yu and v. So we can now use the Leibniz theorem to solve this equation using Leibniz theorem. So here the formula of Leibniz theorem is Fn equal to u v un v plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 plus like that. So for this term we can take 1 minus x square term is u and y2 as v. So let's solve. The term un remains constant, so 1 minus x square. V also remains constant, but we add it n plus 2 because there is the second derivative, so already that's why we add 2 plus n c1. Derivative of this term 1 x square is minus minus 2x, and y n plus 1 because there is a single derivative. Again plus nc2, but the derivative of this term 2x is minus 2, and it becomes yn. We have another term x y1, so we should also use this y1. We also use Leibniz theorem but for this term, so minus x yn plus 1. Derivative of this y1 is minus 1 nc1 yn equal to 0, or we can now simplify this for the required answer. Y1 n plus 2 minus, this term becomes minus 2. The value of n c1 is n x y n plus 1 plus, this term also becomes minus. This term also becomes minus, so minus value of this nc2 is n minus 1 divided by 2 factorial y n minus x y n plus 1 minus the value of this is n y n equal to 0, or Now we can see this is a factorial. So 2 factorial is equal to 2. So this 2 and 2 cancel out. Also we see there is a common term yn plus 1 and yn plus 1. Also there is also another common term yn. Now taking this common, y minus x square yn plus 2 minus 2nx plus x yn plus 1 minus, we can simply open this small bracket, n square minus n plus n yn equal to 0. This n cancel out, or we can simply take this x in common, 1 minus x square yn plus 2 minus 2n plus 1 common x yn plus 1 minus n square yn equal to 0. This is our required answer which is asked in the question. Hope you guys understand this theory, and if you like this video then do thumbs up, like, subscribe and comment also.